Alright guys, welcome back to Chapter 5 of Exam 2 for Statics Review. We're going to be going over number 5.3 in your book in Chapter 5. This problem is going to be a rectangle and a triangle combined, um, as shown here. We need to find the centroid. So what we need to do is distinguish on how we're going to break down these components of this picture so that we can simplify it down and actually solve for everything. So the best form for this one would be to separate them into a rectangle and a triangle. I'm going to label my rectangle as 1 and my triangle as 2. So we have 1 plus 2. Go ahead and draw our rectangle. I'm going to draw mine nice and pretty with straight lines. Plus our triangle, which is just pretty much an upside down right hand triangle. Nice and easy. Now, I have right here this color code right here. So blue dot is going to be our local centroid and our red dot is going to be our global centroid. A global centroid can be found in the entire picture. So we're looking for the global centroid of this entire picture. The local centroid is going to be finding the actual center of each individual shapes. So we know that the local centroid of a rectangle is going to be in the center, half of the width and half of the length. And on a triangle is going to be 2/3 of the base or in the height. So most likely somewhere about right there. So same thing for over in the big drawing. Those are going to be our locals. We can guess that our global is probably going to be somewhere at around there. This is going to help us be sure that when we do our math, our assumption's correct. So the next step that I like to do is I go ahead and solve for my areas. Go ahead and get them out of the way. So an area of a rectangle is pretty straightforward. Length times width, 120 times 100, all in millimeters. We get 120,000 square millimeters. Now we have a triangle. Our triangle is going to be pi r squared over 2, which is going to be, oh, sorry. I was thinking of a circle. Don't know why, but I was. Our triangle is actually going to be base times height over 2, which is going to be our 60 times 120 over 2. Our area for that one, I think it should be 3,600. Yep, 3,600 squared. Now I'm going to write that out a little bit nicer for us to see. So our area for 1 is going to be 120,000 square millimeters. Our area for 2 is 3,600 square millimeters. So now that we have our areas, we can find our local x bar and y bar for each individual shape. So to find our local x bar of our rectangle, it's going to be where the local centroid sits at the center from the x direction of our origin. Make sure we know where our origin at. Make sure that when you do have your stated origin, that is where you start for every point. If you can't have an origin stated here and then start referencing from here, you'll have all your numbers mixed up and you will get the problem wrong. So every time you start at the origin. So starting at the origin to find our center at the x of the rectangle, we go out halfway of our length or our width, which is half of 120, so it's going to be at 60. And that's going to be our x bar. 60. Now we need to find our y bar. Our y bar is going to be on the rectangle, starting from the origin, go up halfway up on the rectangle to find there. So we have to go up the full amount of 60 plus half of the 100. So it's going to be 60 plus 50. We're going to have our y bar be at 110 millimeters. So now that we have those, we can go ahead and do the triangle and go ahead and get it out of our way as well. To find the triangle, we need to break these into thirds. So we're going to have our first tick, second tick, third tick. Same thing for here. We're going to have first tick, second tick, third tick. Now to find our x bar and y bar of the triangle, our local x bar of 2, if we look at it, on our x, we need to take 1/3 times the amount of distance it takes in the x direction, which is going to be 120 millimeters. So our x bar of 2 should be 40 millimeters. We're going to do the same thing for our y bar of the triangle. Now, looking at the y bar, we have to go up in the y direction. So now we've gone up 2 ticks. Instead of on this one, we only went up 1 tick. So if we go up 2 ticks, we need to do the equation 2/3 times our distance in that one, which is going to be 60 millimeters. Which, double checking the math, 2/3 times 60, we're going to have it also be 40 millimeters. Okay, now we just need to take our local x bars times our areas of each individual one. I'm going to go ahead and shorthand this, zoom in so I can write it a little bit easier for you. We're going to have our x bar times our area going to be 7.2 times 10 to the 5th. Now note right here, it's going to be millimeters cubed because you're going to have millimeters times a millimeter squared. Our y bar times our area is going to be 1.32 times 10 to the 6th. Doing the same thing for our triangle, we're going to have 1.44 times 10 to the 5th and 1.44 times 10 to the 5th as well. Okay, so now that we have our table completed, we can go ahead and start summing our forces in our areas. So our sum of areas is going to be 15.6 times 10 to the 3rd. It's going to be square millimeters. Our sum of our x bars times our area is going to be 8.64 times 10 to the 5th. This is going to be cubic meters. And our sum of our y bar times our area is going to be 1.464 times 10 to the 6 cubic meters as well. Now that we have those values, we can use these equations right here given to us from the book to solve for our global x bar and y bar. So, solving for a global x bar, we just take our sum, this is supposed to be sum in between those. It's going to be sum of our x bars times our area over the sum of the area. Doing that math, we get our x bar to be 55.4 millimeters and our y bar to be 93.8 millimeters. And that is it for this problem. The biggest thing you got to watch out for is to know where your origin at, where you're starting on your origin. That is going to be your big kicker. So, now that that one's done, we'll move on to the next problem, which is going to be 5.8. 5.8, based off what we're looking at right here, is going to be a semicircle minus a rectangle. Again, we're finding the centroid, so I'm going to label the semicircle as 1 and our rectangle as 2. So I'm just going to do a vague drawing of them right here. Semicircle, which is 1, minus, because this is a hole, this rectangle is being taken away, minus our rectangle. Drawing it nice and neat. 2. Now that we know those, we start taking our areas. So area of 1 of a, now the area of a semicircle is going to be pi r squared over 2. That was the equation I was trying to use earlier. Which is going to be pi times our radius, which is 38 inches, squared all over 2. We get area 1 to be 2,268.2 square inches. Now we need to find our area of a rectangle, which is going to be 20 inches times 16 inches. We get area 2 to be, but keep in mind we're subtracting this, so it's going to be a negative 320 square inches. Knowing our values, let's go ahead and start plugging them into our table. We get 2,268.2. Keep in mind this is square inches, and negative 320 square inches. Now we need to find our local y bar and x bar for both of these. So the local y bar for a semicircle is going to be somewhere about right there, and the local for rectangle, of course, is going to be about the center of half of the width, half of the height, or half of the length. Our global centroid for this problem is probably going to be somewhere about right here on the main picture. Because we're subtracting this rectangle out, the larger portion of the circle or semicircle is going to be to the right, so that's more likely where our center is going to be. So continuing on, we need to find the center, or sorry, the x bar, which is going to be our local centroid in the x direction of a semicircle. This part you're going to have to refer to the back of your book or the chart that he will give you on the exam. It's going to give you to find the x bar, y bar, and your areas of all different kinds of shapes. So referring to the chart, on a semicircle, it is 0 for the x, and we can prove that by our origin being right here at the center. So it's going to be 0 in the x direction. Now we need to find it in the y direction. To find it in the y direction, our y bar of 1 is going to be 4r over 3 pi. Solving that out, we get 16.13 inches. Those are also inches. Alright, now we're going to do the same thing for the triangle. Or sorry, not the triangle, the rectangle. Now in the rectangle, we have the origin right here, and we have to go to the left, half of 20. So we're going to have a negative 10 inches in the x direction. Now we need to go in the y direction to find the local centroid, which is local is going to be here, and the local, this one's going to be here. So that's going to be half of 16, so we're going to have 8 inches. Now we need to find our x bar times our area. On the semicircle, it's going to be 0. And on the y bar, it's going to be our 16.13 times 2,268.2. We're going to get 36,581 cubic inches. Solving again for x bar times area on the second one, which is our rectangle, we get a negative 32, sorry, it's going to be a positive 3,200 cubic inches. And on the y bar, it would be negative 2,560 cubic inches. Alright, now that we know those, let's take our sum of our areas, which we get 1,948.23 square inches. Sum of our x bars times our area, we get 3,200 cubic inches. Taking our sum of our y bars times our area, we get 34,021 cubic inches. Now we got to take our main equation, which is our global x bar, times our sum of our area is equal to the sum of our little x bar times our area. Same thing for our y bar. Sum of the area is equal to sum of our little area, y bar times our area. Solving those equations out for x bar and y bar, we get x bar to be 1.643 inches and our y bar to be 17.46 inches. And that completes chapter 5. So chapter 4 and chapter 5 are pretty straightforward as long as you kind of know what you're doing and you keep calm and just watch your origins for your chapter 5. Chapter 4, watch your angles, make sure you know how you do your sine and cosines, even when your perfect triangle's flipped around, and you will be just fine. So if you have chapter 4 and chapter 5 really good in your books and you know it really well, but you struggle on chapter 6, start the exam at chapter 6 problems, which is going to be a truss, those problems are going to take you longer. So that completes Chapter 5, Exam 2 review. We're going to start Chapter 6 in the next video, so stay tuned, and we'll see you then.